Today I'm going to talk about simplifying trig expressions, which is chapter 7, section 1 of our pre-calculus book. Before we do anything, we have to always remember the reciprocals and the Pythagorean identities that will help us solve these problems. First, we have tangent x, which can also be represented as sine over cosine. We have cosecant x, which could be 1 over sine, secant x, which can be 1 over cosecant, cotangent, which could be 1 over tangent, or cosine over cosine. And then we have the Pythagorean identities, which are sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. As we are about to start doing some problems, I would like to say that the goal is to keep everything into sine and cosines, because those are the only two variables we cannot reduce. If you notice, everything always finishes with sine or cosine. So if you get everything to sine and cosine, that's a good sign. So let's start with an easy problem. This is our first example. Cosine times tangent. What does it equal to? The first step is we have to transform tangent. We have to make everything in terms of sine or cosine, because those are the two variables we want. And we know that tangent is really sine over cosine, and we already have a cosine here times in the tangent. So if we can transform this tangent to sine over cosine, that's exactly what we want. So then if you notice, we have cosine times sine over cosine. So these two cosines can cancel, and the answer to this problem will be sine. So this is what we want. Now another problem, a little bit harder this time, which is secant squared minus 1 over secant squared over secant x. So this problem is a little bit more complicated. There's a lot more parts to it, so we have to pay attention. We have to remember, to start this problem, we have to go back to our trig identity and see which one do we have. So we're working with secant squared minus 1. And if you could see, this formula has both secant and tangent. So we see in this that tangent squared plus 1 equals secant squared, which means that secant squared minus 1 will equal tangent squared. So that's what we're going to transform our secant squared minus 1 to. Tangent squared of x, because secant squared minus 1 equals tangent squared. And as of our secant, we can see here that secant equals 1 over cosine. So we can go ahead and transform our secant into 1 over cosine like I have here. The next step is to make everything in terms of sine and cosine. As you can see, we still have a tangent in here. But if we go back, we see that tangent is really sine over cosine, even though the tangent in the problem is squared. So this will be sine squared over cosine squared, like I have here. Sine squared over cosine squared equals tangent, and you can see that I went ahead and divided by 1 over cosine, which is my denominator in here. So after this step, we know that we can divide fractions. We have to reciprocal it and cross multiply. So that's exactly what we're gonna do. We're gonna turn a 1 over cosine into cosine squared x over 1, and then we have this sine squared over x, sine squared of x over cosine squared x times cosine squared x over 1. As you can see, this problem became way much easier after I canceled and I transformed everything. So now all we have to do is cross the cosine out and cross both cosines out, and our answer will be sine squared of x. See, this problem looked hard at the beginning, but after we reduced everything and we paid close attention, it wasn't really much. It was 1 step, 2, 3, 4, and boom, we have the answer. It might have looked harder than it really is, but it's just really about attention, and always remembering your your identities, and your reciprocals, which are very important to be successful in chapter 7, section 1. Thank you for your attention.